Hello, in this video we're going to look at solving rational equations. Our main goal in solving a rational equation is to eliminate denominators, eliminate fractions by multiplying by the lowest common denominator. That creates for us an equation that is linear or quadratic, polynomial basically. And in order to make sure that the equation that we get is of the lowest degree possible and therefore easiest to solve possible, we really do want to use the lowest common denominator and not just any common denominator. We also want to pay attention to restrictions because we will occasionally end up with extraneous roots which cannot be used as solutions. So looking at this first basic equation, I note that the non-permissible value here is 0. X cannot equal 0. So if in doing the algebra I were to get an answer of 0, I would have to reject it. I also don't really have to think too hard about the lowest common denominator here because there is only one denominator, x. So basically then I decide to multiply both sides of the equation by x, which will eliminate 4 over x times x is just 4 on the left-hand side. So I end up with 4 equals x. When I compare this with my non-permissible value of 0, there's no problem. So that is my solution. Looking at this next equation, which is a little more complicated, but still relatively straightforward, I note my non-permissible values. So x cannot equal -2 or -3. And my lowest common denominator in this case is just going to be the product of those two denominators because they have no factors in common. Remember that the x plus 2 and the x plus 3 are basically indivisible. They are factors in and of themselves. So the product of these two factors gets multiplied by both sides of the equation. So I'm multiplying the fraction on the left times x plus 2 times x plus 3, and I'm multiplying the fraction on the right by that same common denominator. I want to be very clear that that's what we're doing here from a mathematical standpoint. I have to do the same thing on both sides of the equation. So I'm multiplying both sides of the equation by the same thing, this common denominator. On the left, the effect that has is to cancel the x plus 2's and leave me with x plus 3 times x plus 1. And on the right, the x plus 3's cancel, and what's left is x minus 3 times x plus 2. So my equation is now x plus 3 times x plus 1 equals x minus 3 times x plus 2, which I can distribute and solve. It looks like it's going to be a quadratic equation. So I have x squared plus 4x plus 3 equals x squared minus x minus 6. But what I see here is that it actually doesn't end up being a quadratic equation because the x squareds, if I subtract x squared from both sides, I just have a linear equation. So I end up with 5x equals -9, which tells me that x equals -5/9. I compare this with my non-permissible values. X can't equal -2 or -3, but there's no problem with -5/9. So that is the solution to this rational equation. And finally, let's look at one where we have something a little more complicated. This is an example where I definitely don't just want to use my lowest common denominator as the product of all three of these denominators, because that would end up giving me an equation of a higher degree than necessary that's going to be much harder to solve than I need. So what I want to do is I want to start by factoring any denominators that are factorable. And what I note here is that when I factor, I have common factors. So the lowest common denominator is basically the least common multiple of these denominators, which is just x plus 3 times x minus 3. So there's no reason to include x squared minus 9 again because its two factors are already included. I need to factor anyway to figure out non-permissible values. So x does not equal positive or -3 in this case. So now what's going to happen is I'm going to take this equation and I'm going to multiply both sides, but when I multiply both sides, I actually am going to end up distributing so that I'm multiplying the lowest common denominator by each fraction on both sides of the equation. And so here's what I have. When I multiply both sides, something will cancel in each case, and I will be left with no fractions. So x plus 3 times x minus 3 times 2x over x plus 3, the x plus 3's are going to cancel. If I multiply x plus 3 times x minus 3 times x over x minus 3, it's the x minus 3's that are going to cancel. And on the right-hand side of the equation, the whole lowest common denominator is going to cancel because I have both factors. So x plus 3 times x minus 3 times 18 over x plus 3, x minus 3 is just going to leave me with the 18. So the new equation that I have, well, x minus 3 times 2x, which I can distribute, so that's 2x squared minus 6x, plus x plus 3 times x, well, that's going to be x squared plus 3x, equals 18. And this is a quadratic equation, so I get 3x squared minus 3x minus 18 equals 0. I can divide the whole thing by 3, so I'm dividing both sides of the equation by 3, which gives me x squared minus x minus 6 equals 0 divided by 3, which is still just 0. And now I can factor this quadratic, x minus 3, x plus 2 equals 0, which this quadratic equation has two solutions, x equals 3, x equals negative 2. But if I compare back to my non-permissible values, 3 was a non-permissible value. So I have to reject that solution. And that means that this rational equation only has one solution, x equals negative 2.